Good day, everyone, and welcome to Valenzuela Live in Mathematics for Grade 6. I am teacher Marlene Perduce from Constantine Elementary School, your live streaming teacher for today. And we are now in the first week of the third quarter. For today's objective, which is based on the Department of Education Most Essential Learning Competencies, at the end of the lesson, you should be able to first, visualize and describe the different solid figures such as cube, prism, pyramid, cylinder, cone, and sphere using various concrete and pictorial models. Second is to differentiate solid figures from plane figures. And the last is to identify the faces of a solid figure. So basically, our lesson for today is all about solid figures. So to understand more about solid figures, it will help us if we back up just a little and start out with this one-dimensional object, like this line segment. So to measure a one-dimensional object, we need a one-dimensional quantity, which is usually called a length. And the length of this line segment happens to be the distance between the two endpoints. And if we move or extend this one-dimensional line in a direction perpendicular to it by a certain distance, it forms a two-dimensional object called plane figure. So plane figures are measured by two-dimensional quantities called the length and the width. Not only this rectangle is an example of plane figures. We also have different examples such as square, triangle, trapezoid, parallelograms, rhombus, and circles. Now, imagine that we take this two-dimensional figure and move or extend it in a direction perpendicular to its surface by a certain distance. And it forms a three-dimensional figure. That's called a solid figure. And to measure a solid figure like this, we use the three-dimensional quantity called the length, the width, and the height. So length refers to how long the figure is, while the width refers to how wide the figure is. So from side to side. And height refers to how high or tall the figure. So did you know, class, that solid figures are enclosed by plane figures or curved surfaces? So like, for example, these 6 plane figures, like squares and rectangles, can be used to form a solid figure. And when we put together all these plane figures, planes, points, and line segments, a solid figure is formed. And a solid figure that is composed of polygonal regions or polygons, like in this figure, is called a polyhedron. So a polyhedron has faces, edges, and vertices or vertex. So the faces of the polyhedron are polygonal regions or polygons, like in this figure. So we have the top and the bottom faces, the side-to-side faces, and the front face and the back face. We also have the edges, which are the segments formed by the intersection of two faces, just like in this figure. So we have the top face, and the front face. And when it intersects, it formed a line segment called the edges. And the last is the vertex. It is the common endpoint where the three edges meet. like in this figure again. So we have the 3 edges, 1, 2, 3, and as you can see, they meet at exactly one point, and that point is called the vertex or vertices. Now let's discuss the different examples of solid figures, how they formed, and what is their names. So solids with special properties have special names. And one of the examples of this is our first example, or first type of solid figure. So we have the prism. So the prism is a polyhedron with at least pair of parallel faces. So this is an example of a prism. So the parallel faces of the prism are the bases, the top, and the bottom faces. And the other faces are the lateral faces or the side faces of the solid figure. And a prism is also named according to its bases. But before that, let's discuss first the number of edges and vertices of this prism. So this prism has a total of 12 edges. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And it also has a total of 8 vertices, 4 at the top and 4 at the bottom. So I have here different types of prism, and we can now name this according to its bases. So for our first type of prism, so if a prism has 3 pairs of parallel rectangular bases, we can name it as a rectangular prism. If it has a parallel triangular bases, we can call it as triangular prism. And if the prism has a pentagonal bases, we can call this as the pentagonal prism. And there is a lot of more examples of prism aside from what I have presented. There is also a prism whose faces are regular polygonal regions, meaning to say it has congruent faces and edges. And that is a cube. So cube is a regular polyhedron that has 6 congruent square faces and 12 edges. So let's proceed to another example of a solid figure, and that is the pyramid. So pyramid is a polyhedron with polygonal bases or polygonal base and a triangular lateral faces with a common vertex. So this is an example of a pyramid. So as you can see, it has a base that is a polygon, and it has a triangular faces. And it also has a common vertex, or also called as an apex. So just like the pyramid, just like the prism, let's count the number of edges. So in this figure, it has a total of 8 edges. So let's count. 1, 2, 3, 4, 5, 6, 7, and 8. And it also has a total of 5 vertices. So 1 at the top and 4 at the bottom. So that's a total of 5 vertices. And just like the prism, pyramids can also be named, or different types of pyramid can also be named according to according to the kind of base they have. So like in our first figure, a pyramid with a square base can be called as a square pyramid or a regular pyramid if the base of a pyramid is rectangle we can call this as rectangular pyramid. And for our last figure, if the pyramid has a triangular base, we can call it as a triangular pyramid. And there is also a triangular pyramid made up of 4 congruent equilateral triangles. So when we say equilateral, all the sides of a triangle or of a solid figure has the same measurement. And this is another regular polygon that is called as the tetrahedron. So tetrahedron is a regular polyhedron that has 4 congruent equilateral triangles. But there are some solid figures that are not polyhedrons. And these solid figures are composed of circular regions or circular surfaces, just like the cylinder. So cylinder is like a prism, except that the bases are circular. And these 2 circular bases are congruent and parallel. So when we say cylinder, it has 2 circular bases that are congruent and parallel. Another type of solid, or another example of solid figure with curved surfaces is the cone. So cone is like a pyramid, except that the base is a circular region. And this region is also called the base. And it has a single vertex called an apex. So that is the one at the top. So when we say cone, it has 2 circular bases that are congruent. When we say cone, it has a circular base and it has a common vertex. And for the last example of solid figure is a sphere, which is formed by points in space that are equidistant from the center. So in this figure, the one that is equidistant from the space is the center of the sphere. So when we say equidistance, it means that the center of the sphere has equal distance among the points in the surfaces. So again, when we say sphere, that is formed by points in space that are equidistant from the center. So earlier, I have mentioned that solid figures are formed by plane figures. And to help you see the difference between plane figures and solid figures, imagine that you have a perfectly thin box. If you unfold the box, you can see that the 2-dimensional figure that made up the box can be formed a 3-dimensional closed figure. So a closed plane figures that can be folded into a closed 3-dimensional figure is called the nets. So nets is a closed figure that can be folded into a closed 3-dimensional figure. So plane figures are used to show the nets of a solid figures. So I have here some examples of nets and help me identify what solid figures can be formed out of these nets. So you can type your answer in the comment box. So for our first net, what do you think is a solid figure that can be formed out of these nets? You can type in your answer in the comment section. Okay, for our first net, our first example of net, if we fold the net, as you can see, we can form a three-dimensional figure or a solid figure that is a cube. Very good. So a cube is composed of 6 congruent squares. Another example of a net. What solid figure can be formed out of this net? So again, type in your answer in the comment section. Okay, for this plane figure, we can form a solid figure that is correct, a square pyramid, or a pyramid with a square or with a base of a square. Another example of a net. What do you think will be the solid figure that can be formed out of this? If we have two circles, the one at the top and at the bottom, and a rectangle. So if we combine these three plane figures, or if we fold these three plane figures, what do you think is the solid figure that will be formed? Okay, correct. So the solid figure that will be formed is a cylinder. Another example of a net. So we have 3 rectangles and 2 triangles. Okay, so if we fold this plane figure, we can form a triangular prism. Now that you already know more about the solid figures, let's check your understanding by doing this activity. So all you have to do is to type true in the comment section if the statement is correct and type false if not. Okay, for our first statement, a rectangular prism has 6 faces, 8 edges, and 10 vertices. Is it true or false? Okay, time's up. The correct answer is false. Because a rectangular prism has 6 faces, 12 edges, and 8 vertices. For statement number 2, a cube is a regular polyhedron. Is this statement true or false? Okay, time's up. The correct answer is true. So a cube has 6 congruent square faces and 12 edges. For statement number 3, a polyhedron can have at least 4 faces. Is it true or false? Okay, time's up. The correct answer is, for this statement, that is true. So an example for this is a triangular pyramid that has 4 faces. And each face has a plane figure that is a triangle. For statement number 4, parallel faces have common edge. Is it true or false? Okay, for statement number 4, that is false. So only adjacent faces have common edge. And for the last statement, a prism has at least a pair of parallel faces. Is it true or false? Okay, time's up. The correct answer is false. Okay, so to wrap up our lesson for today, just remember, class, that solid figures has 3 dimensions such as length, width, and height. It is enclosed by plane figures. Another thing is a polyhedron is a solid figure whose sides are all polygons and it has faces, edges, and vertices. So we have different examples of solid figures. Those are prism, pyramid, cylinder, cone, and sphere. And for the last, next is a closed plane figure that can be folded into a 3-dimensional figure. So for your additional activity, please do answer in your Mathematics Quarter 3 Module 1, Activity What's More, page 10. So thank you, grade 6, for your active participation. See you again next time. God bless and enjoy the rest of the day. Bye!